Hi guys, welcome to the second video of your 1C lessons. Today we're going to be looking at the structure of the heart. By the end of this video you should be able to describe the appearance of the heart and its associated vessels. You should be able to explain why the heart is made up of two adjacent pumps, and you should be able to explain how the structure of the heart is related to its functions. So, what do we know about the heart? We know that it's a muscular organ. We know that it pumps blood. I know that you know that it's made up of two different sections. It lies in front of the lungs and is directly connected to them. The cells of the heart are referred to as myocytes, and they need their own blood supply, which you will come to know later on. So if we map the heart as simply as possible, we know that it's divided into two, like so, and then it's divided again into two, like so. What you have is the right atrium and the left atrium, and then you've got the right ventricle, and then you've got the left ventricle. So what you can say is that you have two separate pumps, this side and this side. So this side deals with the blood that's coming back from the body and is being pumped to the lungs. This side deals with the blood that is coming back from the lungs and is to be pumped to the body. So then we've got the atrium on the top, we've got the ventricle on the bottom. So the atrium is the section that receives the blood on either side, and the ventricle is the section that pumps the blood out. It is thin-walled and elastic, so it can receive large volumes of blood depending on the need for it. The ventricle has much thicker muscle, and this is for the contractions to take place. So what you will find is that the right ventricle will have a much thinner wall in comparison to the left ventricle. And this is simply because of the distance that the blood needs to be pumped in the right ventricle is much smaller than the distance that the blood needs to travel in the left ventricle. So when we consider the structure of the heart, there is a thick wall called the septum. So what you have are valves that prevent the backflow of blood. So you have the tricuspid valve, the pulmonary valve, you have the mitral valve, the aortic valve. The tricuspid valve separates the right atrium from the right ventricle. Then the blood needs to flow into the lungs. So you have the pulmonary valve, which prevents the blood flowing back from the pulmonary arteries back into the right ventricle. You may find that these two are referred to as atrioventricular valves, either the right or the left. So the next one you have is the mitral valve, which separates the left atrium from the left ventricle. So this is the oxygenated blood which is coming back from the lungs. Then you have the aortic valve, given by its name. It separates the aorta from the left ventricle to prevent the backflow. So we talked about how the pressure can be different in the different vessels of the circulatory system. So with the aorta, as expected, you'll have really high pressures because it's pumping direct from the heart to the rest of the body. Then it gradually decreases from the arteries to the arterioles, and then you get the capillaries and the veins and the vena cava. The vena cava being the final point before entering the heart. These will have extremely low pressures. Okay, so now we can begin mapping the heart. The vessels connecting to the heart to the lungs are called pulmonary vessels. So what you will find is the pulmonary artery, the left one. This one will be the left. I'll put PA for now. The left pulmonary artery. The vena cava carries the blood on its final route into the heart. So you will have the inferior, the superior vena cava. So superior because it's at the top, inferior because it's at the bottom. If we follow the route of blood from the vena cava, which is the blood that's coming from the body tissues, deoxygenated, ready to be pumped into the lungs. So the vena cava flows through into the cavity of the right atrium. So I'll put R for right. It then will pump through into the right ventricle. And the valve in between these is either the right atrioventricular valve, or you can call it the tricuspid valve. The blood here then will leave through the pulmonary arteries to then get to the lungs. The valve here is the pulmonary valve. The blood has whizzed off into the lungs, it's become oxygenated, and now it needs to return back in to the heart to build the pressure back up to then be transferred into the rest of the body. So the blood is carried in through the pulmonary veins, which we have here, and there's some here behind here. They will enter the left atrium. They will pass down into the left ventricle, and as you can see here, the thickness of the walls here and here are quite different, and this is because we need to contract harder and provide a higher pressure to transfer the blood across into all the different body tissues. So what you have preventing the backflow of blood between the left ventricle and the left atrium is bicuspid valve, or the left atrioventricular valve. What we have here is the septum, and we've come across this before. This is the section, the thick lining of muscle, which prevents the mixing of oxygenated and deoxygenated blood. And here we're referring to the thick muscles. Okay, so we've looked at the inside of the heart and how the blood flows in and out of the heart in the two different sides and the two different pumps. But how does the heart receive its supply of oxygen for its muscles to then have the energy to contract and carry out these tasks? So many will think that the heart is receiving a supply of oxygen as the blood is carried in from the lungs through the left side of the heart. But this isn't true. So the oxygenated blood that is entering from the lungs doesn't get used up in the heart. This oxygenated blood is purely for the use of the body tissues. So the heart muscle is supplied by its own supply of oxygenated blood through arteries on the surface, which you may see when you do your dissection. So these are coronary arteries. So you will find that the coronary arteries are actually almost directly linked to the aorta, just branch off about here and allow a supply of oxygenated blood to get to the heart muscle. And to finish off, The coronary arteries are what become blocked to then lead to diseases such as myocardial infarction. To sum up, we've looked at the heart and the fact that it is divided into two pumps, and we've got the atrium on the top and we've got the ventricles on the bottom. We've got deoxygenated blood entering through the vena cava and leaving through the pulmonary arteries to get to the lungs, and then from the lungs we would get oxygenated blood which enters through the pulmonary veins and leaves out through the aorta to the rest of the body. Okay, so that wraps up today's video. We're going to be doing a dissection in the next lesson, so hope you look forward to that, guys. See you then.